This
presentation.
conference will now be recorded.
We're starting the recording, great. So I'm based in Sydney. I've actually been at Autodesk coming up to 9 years. I was a professional architect, mainly in the UK for 10 years, and I've designed buildings in different parts of the world. Some of the firms that I've had experience at was HOK, Building Design Partnership, working in conjunction with construction-led procurement routes, so heavily working with companies like Langer Rourke and Balfour Beatty Construction, where it was a design build procurement. During my time in industry, probably like yourselves, we've all designed larger and small buildings. I did a lot of universities and schools. Also, when the GFC hit the UK, spent a lot of time trying to win work, especially in the healthcare and charity side of the industry, so government funded projects. The one here on the left was a huge military hospital in Qatar. We were bidding for this one. It was worth £500 million. And on the right, a small rehabilitation school for the British Trust in the UK. Some slightly larger, more complex projects that I was fortunate to work on was working in healthcare and laboratories. For anybody who's done these type of projects, they can be very complex to coordinate with specialist services and specialist extract units. The one on the left here is the Brighton 3T's Trauma Hospital, just outside of the UK. This was actually designed in Revit to work to a precast concrete factory system by Langer Rourke Explores Factory. So each one of those panels has actually been designed for manufacturing and assembly on a large, complex healthcare project. The one here on the right, this one was started in AutoCAD architecture back in the early 2000s. It was a medical research council building for the University of Cambridge in the UK. What happened is when we started it, it was like this. This is ADT back in the olden days, AutoCAD Architectural Desktop, and we were working in zones, working with complex CAD systems to set up different libraries and elements and standards. By the time this project got finished and got built, the contractor ended up redoing it inside of Revit. So here's the project here, rebuilt in Revit, and this is used mainly for facilities. So you can see here all the laboratory elements have been built into the model. This, of course, can be rendered using the Autodesk Cloud A360 rendering. And with all the details, we can also start to use some of the features in Revit, like exploded assembly drawings. So for something that needs a little more explanation, like a laboratory table, you can grab all these elements and pull them apart from the model and create these assembly visuals to better explain how those parts get assembled together on site. Other things that I've been involved with at Autodesk, my claim to fame was designing the Revit sample house. This is the original one. The one that you get with Revit is slightly different. They took out some elements. But this one was built to a high level of detail, a high level of development right down to the timber framing. Plus, there's a lot of hydraulics in it as well. So those are some of the things that I've done in the background whilst either being in industry or working for Autodesk. So just moving to our presentation here. So any questions, just a reminder, if you have any questions, please type them into the chat window. We can do a Q&A at the end. But just feel free, if you see something, just type it in, or think of something you want to ask, just let me know. Ty's online, he can help moderate the questions at the end. So today we're going to be looking at, because I mainly work in the architecture space, we'll be looking at the AEC Collection tools for architecture design, interior design, and urban design. We'll go beyond the collections as well, just to make you aware of some other tools that can help with your workflows. And this is going to be a presentation that we've been developing for our partners and for our customers to sort of explain how far you can go with the software and how it suits all the different types of workflows in industry. So we do have a lot of applications inside of the collection here. So on the top half of this graph, in a linear workflow going from your initial site survey right through to schematic design, documentation, and ideally asset management or facilities management, we have all these different products along the top that can help you with your workflow. So whether it be Recap 360, InfoWorks, Revit, of course, or maybe Dynamo, these can help strengthen your design process. Some of the products I'll be talking about, which are outside of the AEC collections, are going to be these ones on the bottom. So I'll be touching on tools like CFD, computational fluid dynamics, our BIM 360 design for collaboration, and BIM 360 docs for documentation, and also Inventor for fabrication. So just to remind you, the ones on the top are the ones that are in the AEC collection, and the ones on the bottom aren't, but they can help with your workflows. So let's begin with site and survey. We typically need to have a site whenever we start doing a building project, and I'll be working with this demo data set. If anybody wants access to this data set at the end of it, please let me know. It's been built to a high level of development, so it's a nice little demo data set to explore our AEC collections with. So we're going to be looking at 3 products here that are inside the AEC collection: Recap Pro, Civil 3D, and InfoWorks 360. These all fit into capturing site information, but also doing conceptual master planning or urban design. So we're going to look at Recap 360 for photogrammetry capture of existing site buildings. This is where you use drones or cameras to actually scan the site. We're also going to look at Civil 3D and its connection to BIM 360 and how you can create some topographical information with InfoWorks 360 and IMX files. So we'll get into this in a little more detail, some videos. First of all, I just want to explain what's in the Recap 360 Pro. There's the option to use your desktop application to work with laser scans on the right. So if you're working with Faro or Leica, you can bring in those raw scan data, and then you can configure them, like you can get all the scan control points, load them into Recap, and then spit out a RCM or RCP file to load into Revit or your particular authoring program. On the left here, we have photogrammetry, and this is very popular for large sites where you can fly over them with drones, and you can take the photographs that you capture the drones and stitch them into 3D models. There's also the Leica scanner here as well, which is a very simple and easy portable scanner to use, and that can also capture site information. So there's 2 ways that you can capture the information and then use it within the Recap 360 Pro application. So as mentioned, data capture, this is the laser scans for the sourcing, or it could be photogrammetry data depending on how you capture it. What we do is we take that information and we load it into either Recap natively inside of the desktop product, or we can go to the cloud and take that photographic data and it will stitch it together. The results here is that we can optimize that data. There's also tools to clean it up and then reuse that clean data, that optimized data inside of your authoring tools like Revit or AutoCAD or Civil 3D. So I've got a quick example of a drone photogrammetry scan of a large site that one of my colleagues did in Singapore. And this is the video. So hopefully there's not too much lag. What we do have here is the Recap 360 interface, and they've gone and captured all these photographs and they've loaded them in to the file. Recap knows how to stitch the information together. Now, to certain sections, if you haven't flown over them or there's a lot of reflections, it may show certain holes. But usually if it's an overcast day and there's not too much contrast, you can get some really good topography information just by using a basic drone. So that's what it looks like inside the application. I'll just go back to the beginning here. It's just photographs. You load them onto the Recap 360. It stitches them together, and then you have a 3D site for you to work with. So that's more of the macro scale. If we want to go a little bit closer and actually get down to a more detailed site, This is another one that one of my colleagues worked on. This is where they don't have a drone, but they're just going around an existing building and they're taking photographs and loading them into Recap 360 and creating a site building. So you don't have to have that many photographs for this to work. Of course, the more photographs you have going all the way around the building at high, mid, and low levels, the more accurate it's going to be. You can literally load thousands of photos into this application if you want to get really detailed. It did used to be limited, but now we have unlimited amount of photos, almost unlimited amount of photos. So just to show you what this looks like, you can import either your local files or this one's importing from the cloud. So what we're doing is we've got those photos, we've converted them on the cloud, and now we're loading them into our Recap 360 Pro. And here's the quality you're going to get. Now, of course, it's not going to be perfect. It requires a little bit of cleanup. But basically, this is just half a dozen photos. We can take that information, export it out from Recap 360. So it goes from the photogrammetry into the RCM or RCP file format. And now we can load it into Revit. And just for this simple design, it's a feasibility study. We just want to put some design options on it for cladding. That's all we really need. So we haven't had to go out and get a survey. We haven't to go tape and measures, get all worked out accurately. We can simply use that as the context for us to do our initial conceptual design on that particular site. Now, going into other applications that can capture the site, inside of your AEC collections, we have a tool called InfraWorks 360. And this allows you to pull down free data from OpenStreetMaps to create your site. Now, it is from OpenStreetMaps, so it's unpaid data. If you do want more accurate data with all the latest features, I'd recommend locally in Australia, you look at Nearmap, or we also have a partnership with Esri. But if you're just wanting to do a quick conceptual master plan design, this is what you can do inside of InfraWorks 360 with the model builder. So the site I have here on the screen is Singapore, and some of these buildings have been captured from the model builder. Others I just got from the SketchUp warehouse. I brought them in and positioned them on site to give us a quick fly around of what the Singaporean harbour is like here. So the video I have here is how you go and use your model builder to capture the site. So all you got to do is choose your location in the world, and you can put in your exact street address that you want. I'm just going to choose Singapore and navigate into the main bay here, to the main marina. And what I want to do is capture a certain area. Now, you can go right up to 200 square kilometers should you want. So you can pull down some pretty large site data here. This one I'm going to keep it under a square kilometer. What it's got here is it's got basic topography information, and that's based on DEM data. So it's going to be within meter accuracy. You're not going to get millimeter accuracy with this. We've got the imagery coming from Bing Maps. We've got buildings that are available, and these are basic buildings, roads, and in some cases there are underground services available as well, so underground train lines. So that's gone to the cloud and it's pulled down this model for us. So this is what you're going to get for free out of InfraWorks 360 if you need a site to begin with. And again, this could be for feasibility study, just for conceptual design, you just want a basic idea. Now, let's say we want to go a little bit further with this. I do excuse me, my fan is running a little bit hot on my computer. Hopefully that's not interfering with the audio too much. What we can do here is we can export it out from InfraWorks as an IMX file format. Now you can do it as FBX or convert to other file formats as needed. Basically what this is going to do is going to allow you to bring it into our Civil 3D application for more deeper development. So just bear with me, I'm just going to sort out my fan. I'm getting pretty close to renewing my computer. It's a special computer which can be overclocked, and sometimes when you have it turned up on turbo, it can fire up the fan when it gets a bit hot. Okay, so I apologize about any audio issues here. So what I just did before was I pulled down that data from InfoWorks 360, great application you get in the AEC Collection. You pull the data down from the cloud, you've got a free site model. But let's say you want to take it into a vector-based application. You can bring this into Civil 3D. So what I did was I exported out from InfoWorks an IMX file, and now I've imported to Civil 3D. And now we're starting to see something a bit more familiar in terms of some basic topographical information, some contours here. We've got the layouts of the roads, and in certain points there is some underground information here as well. So again, it's a great quick way to get some basic information to start your site master planning or urban designing, just site context for your buildings. Now, I'm bringing this in. I'm just going to use some default coordinate systems. If you're familiar with world coordinate systems, then you can set this all up. In Australia, we use the map grid of Australia. And again, this is always changing. I do believe the one in Perth has changed just recently. So it's always good to work with a surveyor to make sure you're using the right map grid system. But here we have our IMX file that's been exported out of that free Civil 3D, Civil InfoWorks 360 file. And here's what we're getting. So we're starting to get some information about the grading. We've got the topography information. It's all being put onto layers for us. We can select on that information and we can start to look at what the data is. Over here on the right is some of the information about the underground train line services. All the roads are there. But it's a great starting point for conceptual design. Now, let's say you're not a AutoCAD person or a Civil 3D or InfoWorks person. You just want to work on this in Revit. What we can do now with BIM 360 is we can link that Civil 3D file into Revit and use it as a topography file. Now, again, it is conceptual modeling. It's not perfect surveying. So if you're doing this for a large site, it will work really well. Just wanted to show what this looks like when you use it inside of Revit. You want to connect that Civil 3D file and collaborate into the Revit environment. So here we want to publish the surfaces. So you can see there's some information here on the transportation, proposed ground, existing ground. It says AIW, Autodesk InfoWorks. That's where we captured those sources from, and it's converted into surfaces. All I'm doing here is I want to save this information out. Now, this one I'm just going to save as my DWG. And what I want to do is maybe even filter through some of the information, depending on what wanting to save it out is. I'm just going to go with the defaults here. Again, it's talking about inaccurate results. We do know that this is a conceptual model that we pulled down for free. As mentioned, check out Nearmap or Esri if you want more detailed data. What we've got here is we've got that file saved out, and we want to bring it into Revit. So here we can link the topography that we've saved from Civil 3D into Revit. So here we have the OTX Singapore file, and I haven't bothered with share coordinates. This is the file that I've linked in, and I'm just going to ignore those pop-ups. It's just stuff to do with proposed ground. But you can see here, I've got that topography information that I pulled down from InfoWorks 360 and configured with Civil 3D loaded into Revit. So that's the basic 101 out-of-the-box demo. Of course, if you spend more time configuring it and sorting it out and cleaning it up, you can get some great results. I would use this for the large-scale master planning. I think anything more detailed, you want to look at a paid service for capturing the data. But this could still be a great one to use if you're doing very quick conceptual workflows without having to create all this information yourself in a very short amount of time. Okay, so moving into the conceptual design space, so we've got a few tools here that can help get you up and running. The ones I want to recommend are 3ds Max, Dynamo, and Insight 360 for doing analysis on how that building might perform, whether it be energy use index or solar or daylighting analysis. And one that's outside of the AEC collections is Civil 3D, and this could be doing the wind wake analysis of how wind loads may affect the building on the facade or going around the building and speeding up and affecting the immediate environment. So we're looking at Dynamo for Revit, and we'll have a video showing you how you can use it to optimize your design or facade options. 3ds Max, it's a great rendering tool that's used in movies and gaming, but it's also a very powerful modeling engine to do quick conceptual designs. We also have the energy use index and daylighting tools inside of Insight 360 for analysis, and we have CFD for the wind wake analysis. So 3ds Max is across all of our collections. It's in the AEC collection. It's been there for a long time. It has a great tool to link your Revit files into 3ds Max if you want to do high-end renders. There's other things like if you want to do special types of cartoon type renders, you can use these things called OSL shaders, which is kind of cool. And we've got the Arnold rendering engine inside of 3ds Max now, which is free. That replaces our Mental Ray rendering engine. So probably a lot of people don't know, but 3ds Max actually has a number of AEC design tools. So here we've got stair tools, bifold door tools, we've got steel profiles. All of this can be very quickly used to mass up and design a building without having to go to visual scripting or having to make it manually and then group it and muck around. It's got these powerful tools built into it. So you don't need to know all 3ds Max. If you just knew 5% of it, it's a really handy tool. And then to render it, there are so many powerful rendering engines that are available. One of my personal favorites is V-Ray. V-Ray is one of our partners. You can get renderings out like this in minutes with these type of rendering engines. Again, it's conceptual design. You just build it all in 3ds Max and render it in 3ds Max. It's lightweight. You can get some great results. Another thing that V-Ray have done is they've created a cloud rendering engine for animations. So what I can do here is I can render out this large building of 900 frames, but I can do it within 40 minutes on the V-Ray cloud and then load it back into the 3ds Max environment and create a movie. So this is a pretty detailed data set. You can see there's a lot of fins, there's curved objects, it's got trees, it's got people, it's got all the plant equipment. This took 41 minutes to render this 900 frame animation on the cloud. Just to do one frame sometimes in a rendering engine can take 40 minutes. So to do 900 frames in 40 minutes is pretty powerful. And I didn't hold back on adding a couple of trees and detailed people in here. So it's a great conceptual design, modeling, and rendering tool for your workflows in the AEC collections. Dynamo is growing really fast. Now, you don't necessarily have to be a Dynamo expert to learn scripts, but it does help to know one or two or to have someone in your practice who knows how to use it. This particular script was used for the facade design of the building, and I got some help from one of our specialists, Andrew Milford, in consulting. He helped me put together a script which looks at the sun path analysis on the facade of this building. So inside of Revit, what I'm doing is I'm just firing up the Dynamo visual programming studio editor here, and I'm just loading up this script that Andrew shared with me. Now this can be used again and again on all projects. So it's just what's called a DYN file. And you can see there's a whole lot of nodes and wires that's looping all this information together. There's a little pseudo color range for an overlay on the facade. I don't need to know how to use all of that. All I need to know is how to connect it to my Revit model. So all I'm doing here is I want to select the top floor level where my facade is going to finish. So I'm going to select that floor, and then I select the bottom floor level where the facade is going to start, and that's now connected to the Revit model, and I'll hit run, and that will now create that facade design. Now, this is a curved facade. We were just playing around with some of the ideas of what this could be. Now, if I want to flex it, here within the nodes, sliders that allow me to flex how many curtain panels we want to have. So again, it's just basic sliders, 10 floors, 12 panels. We can either increase it or we can drop it down. I'm going to just reduce it down to say 6 by 6 and then run it. This will go from being the 10 by 12 to the 6 by 6, and that will adjust automatically. So the great thing about this tool is once you've got it set up and you want to drive different options, you can do it with the Dynamo tool. It's design automation using visual programming to run those tasks for you. So that's a handy little way to use Dynamo in the conceptual space to test some design options. If you do want to know more about these sort of tools or about that particular workflow, we have some really powerful users out there. If you search for Dynamo, Autodesk Dynamo workflows on a YouTube channel, you'll find thousands of videos. This one's pretty cool, similar to what I just showed. It's by a user called Jeremy Rowe, and he does some really advanced curling walling panels with the sun and the azimuth and the altitude, with the sun going around the building, and then how those building panels will adapt with shading devices to best shade that type of curved facade. So if you want to know more about this, please check out some of these power users out there like Jeremy Rowe. We've got Insight 360 for our conceptual energy analysis, and I do have to stress that it's conceptual. It's not going to be Section J approved. It's going to be guidance for you to help drive design options inside of your workflows, as opposed to meeting local codes within the part of the country you're in, or working with the local national codes. So what this is going to do is it's going to allow you to start looking at solar analysis, daylighting analysis, and energy use index, how things are going to maybe what they're going to cost when you add double glazing as opposed to single glazing, or you want to make changes to how the buildings run. So in the first workflow video here, we're going to be looking at the lighting analysis. So for this particular building, we want to have some shading devices, but we also maybe want to look at how we can get light into the depth of the floor plan. So instead of having to run the electrical lighting, the artificial lighting 24/7, maybe we can naturally light the space. So do we need more lights in these corridors, or could we put more windows in here? We can start to ascertain by running this lighting analysis what our illumination levels are going to be. And we've got this little illuminance overlay here to sort of show the lux levels at certain points. So quite bright around the facade, but a little bit dark towards the end here. And we can also go back to like styling it in the way we have with the Ecotech platforms to give it that type of color gradient. So when you set this up, you can do it with your Revit model. You can even do it with conceptual design with our format application, but that's very basic. I'd recommend using Revit here. Now, what you're seeing here is our artificial lighting with these tubular lights, and our daylighting giving off illumination at certain times of the day. So we can see our direct lighting, we can see our artificial lighting, and again, it's not as bright as daylight. It's going to be a little bit lower, like I think 3,200 is the correct illumination level for that. So you can see that's why it's showing red. And then of course our darker points are showing blue down here. So to get this running, what you can do is in your Revit environment, you can send it to the cloud and run it from sunrise to sunset. So just before I run this video, this one's been set up, just a camera inside a Revit model, and we have the date. So in April, and we want to start at 8:52 and go to sunset, and I guess it's like going into winter. So when I hit play here, you'll start to see the sun at 10:52, 11:52. We're starting to get a bit of light coming in. Then later in the day, we're starting to get that low winter sun penetrating the floor slab. So maybe on one side of the building, we might want to consider some sort of shading devices, whether external or maybe internal. Maybe they could be automatic, mechanical. But with this basic tool, we can just run on the cloud. It doesn't have to run on your computer, and we can instantly see how much sun is entering the space during different times of day of that April sun path. We can do this both for winter and for summer. So on the left, sorry, we're looking at winter. The exposure has been adjusted a bit more here to make it a bit brighter. But this is where we're not getting as much sun penetration. And you'll see on the right, this is our summer sun penetration. So it's going a little bit slow here. So this playing. So you'll see that because it's summertime, the sun is a lot higher. So it's not going to be having that low summer sun penetrating the building as much. We'll see it come in a little bit, but it shouldn't run as deep. Whereas the one on the left, you can see it's running a lot deeper. That's more your winter sun here. So some really handy tools to give you an idea of how it's going to work with your sun path analysis. Moving into conceptual CFD, computational fluid dynamics. This is when we can start to position our building in the city and start to understand how wind wake might affect it. And we've had customers in New Zealand and Wellington who are starting to use this because they've got a very windy harbour, and every time they design a building, they need to assess whether the wind is going to build up around the building and then go onto the streets and knock pedestrians off their feet. That's how bad the winds are there. So what this does is you can load in your models, so whether it be from Revit, from Forma, it could be from SketchUp or Rhino, or whatever conceptual package you're going to use. You can load into the CFD package as an FBX, and you can start to set up the wind velocity. So this demo here has the wind speed running at 10 meters per second. I've created an artificial wind tunnel here, and we can basically set it up to run and then move around the buildings. And the longer you leave it, the more it's going to refine, and you'll be able to instantly see where the pinch points are for the wind going around the building. This is what it looks like in the package, so how you set it up. And again, you can start to examine that wind flow in several different ways. And this is done for interiors as well, if you want to use it with artificial air handling units. If you want to set up the wind flow from a diffuser, from a mechanical supply air diffuser, you can set that up and look at thermal comfort of users inside a space. Here we're looking at wind flow going around this building and when it's starting to get high. So you can sort of see here up on the left hand side, the velocity is speeding up. So these red points are dangerous points if you're walking around that building, cylindrical building, and the winds are blowing, you could get blown off your feet. Little mini wind tunnels right there. Basically, you can work with really simple models. You don't have to be an expert in terms of making the models, and then you can configure how you want to refine it. And we've got some basic workflow videos of how we're sort of doing this. So we're setting up some planes to cut the building. Now, it could just be a wind tunnel, or you may just want to work with a plane here. We can do this vertically or horizontally. So as we drag that plane up and down the building, you can start to see maybe higher up the wind speed is a lot more quicker in terms of the velocity, and as we get a little bit lower, it's slowing down a little bit. We can also display it with vector arrows as well. There's also another one for doing ISOs as well, ISO surfaces for the interiors, and we can change the appearance and so on. So this is a really handy tool should you want to go beyond your AEC collections. This is CFD for analyzing your buildings. And then finally, just a quick video just showing the wind going over here. And again, they use this for wind tunnel tests for cars and airplanes. Okay, so moving into developed design, and we're going to be getting into a lot of our core products here. So Revit, of course, is going to be our main detailed and developed design application. There are other tools like Dynamo to help you with your documentation automation. You may need to be using tools like 3ds Max to do photorealistic renders to communicate what your detailed design is going to look like. And then we've got other tools outside of the AEC collections like BIM 360 Design for design collaboration, BIM 360 Docs for document management, sharing all your documents as an online file, and BIM 360 Glue, which is used for model coordination. So what we've been doing, just to kick off on Revit, just so you can understand where Revit's going, we're trying to improve how we connect teams integrating with the products, and that's where we have Revit working with Revit Cloud Work Sharing on BIM 360. We're also trying to improve how we create and author information or automate it. With the Dynamo Player, we've got a new tool called Project Refinery as well, and even a headless version of Revit called Revit.io, if you're wanting to get into that side of the engine on our Forge engine. And then finally, we're always looking at how we can optimize the data we're working with. So whether we're analyzing it or we're looking at how it can be used further downstream for operations management, maintenance, or data extraction for contractors. We're working on these 3 core principles. So these have been released now. We do now have PDFs into Revit. You can bring those PDFs in, and it works really well. It understands the vector components of a PDF, and you can snap to it, and PDFs will now read in Revit. No more having to convert it into JPGs. You can now publish cloud model directly into Revit from the home screen. You don't have to go to the publish pop-up. We can start to upload Revit cloud work sharing models as saved as a cloud model. So if you're working in a collaborative environment with Revit Cloud Work Sharing or Revit Work Sharing, you don't need to do that anymore to put onto the cloud. You can actually do it now, save directly to BIM 360 Docs on its own. And we've been improving how you bring in SketchUp files as well. So if you're keen to bring in your SketchUp information to Revit, that was improved in this version. Other things we've been improving, there's been requests for elliptical walls. So this is now being added, improved rebar, copy and move logic, multi-rebar annotation to concrete faces, multi-rebar annotation for freeform rebar, and rebar in model in place stairs. So these things are helping, especially with our concrete users. For path of travel, this was a new one released this year where you can start to work out your escape path. So you can draw a line from your core to your exit doors, or from your furthest part of the building to the core, and it will know where the doors are, and it will start to work out the best path of travel. We have improved OR and view filters if you need to do that for your filtering. And we've got a better material user interface, image and PDF improvements, better tools for tag, schedule, and view filters for elevations, and track and edit scope box parameters in the view list. So just little things that we've been adding to the application. So to see a couple of these, so if I just play here, PDF into Revit, just a handy little tool.
You can now insert a PDF in Revit. The PDF will be placed as a 2D object in the current view only, similar to previous image functionality. You can modify your PDF like any other image and manage the PDF in the Manage Images dialog. This resizable dialog newly supports adding or reloading a PDF. With the PDF button in the Insert tab, there's an option for large or small thumbnails. If there are multiple pages, you can select the page with the thumbnail or by number. The page number and the page size of PDF are reported in the type properties. The resolution of the PDF can be adjusted.
So pretty simple stuff here, but powerful for your workflows. What I will just note here is if you want to see all these videos, we do have the YouTube Building Solutions website, and the presenter there, Emily from the technical marketing team, has actually put together a few videos here to actually take you through those workflows. So if you need to watch these again, they're all here on the Autodesk Building Solutions website. And this has stuff on Revit, stuff on other applications, stuff on what users are doing, all available to keep you updated on new features as they get released inside of products or collections. So I'll just go forward just a little bit. This one is just the splash screen for Revit from 2019.2. You now have a splash screen here where you can actually see your BIM 360 environment, and you can
for increased workflow efficiency.
You can publish it directly from the splash screen. So in the past, you used to have to go and do a pop-up for anybody who's using BIM 360, and you have to wait for that to do it. Now you don't even need to fire up the project. It will just tell you there's an update available from Revit Cloud Work Sharing, and then you can publish it, and then that published model is going to be available for you to view inside of the BIM 360 Cloud. Path of travel. So path of travel is looking at the distance to get from point A to point B. So the one we have on the screen here is maybe from a nurse's station to a patient's room, or it could be from the furthest corner of the building to the escape court. So all we need to do is basically draw a direct line from point A to point B, and it will find that path of travel and go to the doors and go through it. It will also allow us to schedule the information. So we can start to look at the speed that we're going to be going at, what level it's on, maybe the distance if we want to take that out. Sorry, the length here is in imperial, and then the amount of time it takes to get there. So these are just some basic, simple tools that can really help you work your designs. There's other tools where you can start to do alternative paths as well, which will be improving. So all of these things are available in the newer versions of Revit. If you do want to get into design automation in Revit as well, we've got some really powerful users out there doing some really cool stuff. This is one user called Paul Winter from Parametric Monkey. He's got some really good tools to help you with your startups. So just to automate some of the mundane things you might do when you start a Revit project, things to do with documentation, which you might not like renumbering doors and windows. He's got tools for that. He even goes into management tools and analysis tools. So if you're based in New South Wales and you've got to follow SEP 65 solar access, he's written a Dynamo script for that as well. So I'm just going to show a couple here. This is what it looks like inside the platform. So instead of firing up the nodes and the wires of the Dynamo, what do we call it, the Dynamo Studio, this is just the Dynamo player. So the Dynamo player will allow you to play a script without having to open it. So some of those ones in the startup, or some of the things you need to modify, create and rename a work set. You can do that. Add elements on work sets. You can do that. This goes through model groups to work sets, isolated work set views. All he's doing is he's taking this particular drawing and he's just hitting the script, and it's going to do the stuff automatically for him. So you can start to see here is a whole lot of names, but he wants to bring in those sheets from Excel. So on a big project, there may be someone working out all the sheets that we're going to be delivering for the project. If you want to bring them in, you can actually bring them in from that Excel spreadsheet, and it's going to set them up for you. Other things we've got here, title block instance parameters, sheet name to uppercase, a simple thing. If everything's lowercase and you want it to be uppercase, you can do that. So let's just see, did that play? Oh, sorry. So that's going to change to all from lowercase to uppercase inside of the project browser. Then view name to uppercase, you can do all that. And then there's other things like delete unused filters. This one is renaming the room numbers. So if you've gone and done all the room numbers, you have to go back and renumber them all, especially on a large, boring project. You can go and use that script. So here he is. He's got his renumber rooms, and you've got a prefix. So you can prefix the number, whether it's A or no, number, or it could be alphanumeric. Then the actual room number, so .01, all of that can be set up. He can go and use that spline to do the direction of the rooms, and then run the script, and it is going to renumber the rooms automatically for them. So you can imagine how great this will be on a large healthcare project or a very complex project which has a lot of different room numbers. So that's in essence what you can do inside of your document development using the Dynamo player to help automate some of those mundane tasks. So visualization, now some people do send this out of the house, some people use Enscape, Lumion. We have Arnold, which is inside of the AEC collections now. Arnold, its claim to fame, it was used on the Star Wars movies. It's a powerful rendering engine. It's got some really good physical materials and lighting, so you can get some really good results. It's great for working with maybe some of the newer graphics cards. If you've got like an NVIDIA RTX card, you can start to benefit from GPU rendering. In the past, older devices maybe look at the CPU or only using part of the GPU. This is where you can really start to leverage those expensive graphics cards and use your GPU rendering. Other things you can do is you can start to look at rendering almost in real time. Because these graphics cards, these new cards are so powerful now, you can pretty much fire up a real-time render window, and as you make design changes to your scene, you can see it almost render in real time and see how it's going to produce. So really powerful new features with this new rendering engine that's part of your AEC collections. It's free, you don't have to pay for it. You've got this new tool which will help leverage your graphics cards to give you photorealistic renderings. Quick example here. Now again, I'm not as good as the guys who do the renderings in Star Wars, but here we have a Revit model linked to 3ds Max using the Arnold rendering engine. So here I have a pretty detailed model. I mean, there's a lot of nuts and bolts in this model with the steel connection details. What I'm doing here is I'm just saving it out as an FBX file. And then inside of Revit, I'm linking that in. Now you can actually link the Revit files directly, just comes down to user preference. I'm just doing this as a standalone FBX file. Now for those unfamiliar with FBX, it brings in the textures, the geometry, and some of the lighting environment. I can combine it via Revit category. And then when this comes in, it's going to come in with information from Revit ready to go. So you can see some of the materials can be ready and reused. It will even start to display things as boxes if it's heavy geometry. All I'm doing here is adding some Arnold lights and some physical cameras. And when I go to that camera and want to do a render, I can fire up the rendering engine, which is Arnold. And there's some basic settings here that I can use. The Arnold rendering engine is pretty easy to get familiar with. I'll just leave it on the default settings and hit render. And this will now go into the calcs, and it will do the initial bucket pass, and then it will start to fine tune it based on the calculations it needs to do for reflections and refractive materials with light passing through them, and the type of skylighting in terms of the HDRI you're going to be using. So this one took a couple minutes, and this is the quality by just doing an out of the box renderer. So that is your Arnold rendering engine, which is part of 3ds Max included in your AEC collections. Now, we do have another really powerful application called Navisworks. We've had this for a long time. We are keeping it in the collections, but we're also building on it with our BIM 360 Glue application. Navisworks is really powerful for bringing in numerous file formats. It reads up to 56 different file formats, and it's got clash detection tools, timeliner sequencing tools, quantity takeoff, and even a rendering engine. So for anybody who's not familiar with Navisworks and doing clash detection, it's its most popular feature. What we can do here is we can bring in our models. So what we do is we create what's called a federated model. So here we have the mechanical model versus the structural engineering model. And I'm just going and just using the default settings here, tolerance of 0.02 of a meter. And I'm going to run the test. And what it's going to do is it's going to go through the entire model and highlight where there are clashes in my model. So that bit of ductwork isn't going to fit through that cellular beam. That's going to be a problem if we don't get it ironed out now on site. So we want to make sure that that is highlighted. So what we can do is we can assign that to someone in our team. So I'll assign it to Stefan and say, please make your beams bigger for our duct runs. And I can then go and export this report out and send it to him, and he'll have all these items assigned to him that he needs to go and work on. There's even tools like Switchback where he can go back into his model and connect to Navisworks. But here's the report. So there's all these items. You'll see they're assigned to certain people. They're either approved or need reviewing. And this is your Navisworks clash avoidance feature. Our next generation of this is our BIM 360 model coordination. Now, currently it's called BIM 360 Glue, but we are moving it to being a new name under model coordination, and this is going to be our next generation. It's got what's called an automatic clash detection matrix, and it does things like issue tracking on the cloud. So I'll show you a little video on what that looks like. So I'm just opening this up from our BIM 360 platform. And I'm opening up the feature. All these models are loaded and they're automatically clashing. So I don't actually have to run a clash detection report. I can see how all the models are clashing together, or I can go and choose the models that I want to run a clash detection on. So here I've chosen 3 models. So over here on the left are my models, and here are all the things that are clashing. So when I go through each of those 191 clashes, I can visually review them, and I can even break down on the selection tree hierarchy there what's actually clashing. But I can now, instead of running that report like in Navisworks, I can do it directly from the cloud. So I don't need to download a report, send it out to Stefan or Alan or someone on my team. I can assign it to someone directly in my team. So Stefan, again, I want to have him move the beams around to suit my ductwork, and I can create that issue. So he's going to get an email notification and click that link, and it's going to take him straight into the model, and he's going to see what the problems are with the design. So moving into the final part of the presentation, I know we're getting to the hour, so just looking at the detail you can go to with the AEC collections. Now, if you're not familiar with the level of development within the BIM industry, it goes from 100 to 500. 400 or 350 is getting into fabrication type of detailing. So this is where you're going to be adding all the nuts and the bolts, and the next level is what you could do for facilities management and maintenance. So with LOD 400, there are some online tools to advise you on what each one means. This one's from NatSpec, the Australian authority for helping us with our specifications, and they also have a Keynote system as well, which you can load into Revit. So we're looking at LOD 400, and this is where we're getting to detailing, fabrication, assembly, installation, and other information. Then the other one is sort of getting into the verified information. Again, it could be non-graphical. This is where you might have your verified information for as-built for facility management and maintenance. So why do LOD 400? Well, a lot of industries are moving into it. So we have the BIM MEPOS now starting to develop generic design content and manufacturer's content to LOD 300, 350 and LOD 400, 500. This just means that you can use proper real-world equipment loaded to the space for some of this equipment. Also have clearance zones as well for maintenance. It's all certified, and it just helps ensure that what you're designing and building is correct, and then it can be used for workflows when the building's commissioned, as part of that as-built LOD 500 model. So we're moving into Revit, tools like Advanced Steel, and even Inventor for these type of workflows. So I'm just going to touch on these three. We have Advanced Steel, and Advanced Steel is really cool for doing things like connection details as well. This is Richard Rogers' building in Sydney in Australia, and you can see they've got some pretty beautifully detailed connections for the cross bracing of this building. How can we try and do these inside of Revit without having to be a specialist? We can do this with the Advanced Steel automated steel connection tools. So what I've got here is a couple of connections that I was just learning. Again, I'm not an expert. I would go to someone who's a steel detailer and ask for the final advice, or they could open up my model and add these details. So this is the basic workflow. I've got my beams in place, and I want to start to use some of the tools to connect it. So here we have available connections that we can load into our database. So I can either do all connections or filter through the ones I want. I can then go and grab the 3 elements that I want to connect. So my main beam here and the 2 braces, and I can choose the type of connection that would best work with that space. So the one that I want to look at today is a eye bracing splice. So this will basically load into my project and connect them up. Now again, it's not a perfect connection, but I can still go on and add or configure this as needed, but it's a great way to add all the plates and the bolts and the welds that might be needed for that type of configuration. I can then go and open up the properties of that and then start to fine tune it, or have a Advanced Steel expert or a fabricator come in and start to adjust it. So it's a really powerful tool, and you can see, all the bolts and the washers all added. And if you're wanting to work to LOD 400, this is a great automation tool to help with it. Another one we have here is concrete. We've got advanced concrete now coming into Revit, precast concrete, and this allows you to take a standard wall and then break it up into the precast concrete dimensions with all the details you need for the hangers and other little bits and pieces for a typical precast concrete assembly. So the workflow we have here is you've got to install the precast concrete tab. I've just got a basic wall here, haven't done anything with it. It's a basic 200 mm wide wall. And what I want to do is go to my precast concrete configuration. Now again, you'd be wanting to work with the fabricator on this. So go to the fabricator and ask them, what size can you work to? How do we set this up? What you can do is you can then, save this out and reuse it. So we have built-in parts for annotations, dimensionings, the CAM export, like the Unicheck file versions, all of that's ready to go. All we need to do once we've got that information is we can go and split up those walls accordingly. And this will go through my basic wall and convert it into precast concrete panels. So you can see all the connections, or the rebar starters and bits and pieces are there, ready to go. And now I've got my wall made into an actual LOD 400 element. Now, once that's done, I want to not only have it in a model environment, I want to create some views to go on a sheet. So this basically grabs the information as a number of assemblies and generates views, and then I can bring these views into my sheet. So what I've done here is I decided to generate some views, and what I can do is I can drag that information that's applicable to that particular part, because we've broken it down into a precast concrete part, and we can load it into our sheets. So all I'm doing here is just grabbing the information that's needed. I don't need to schedule anything. I don't need to go and create views or sections or whatever in the model. It just does it automatically. And with a few minutes, I can drag all this information onto my sheet. And here I have a typical precast concrete panel ready for a fabricator to work off. Now, hopefully you can export it out and share the building information modeling data with them. But if they're not ready to use that, you can still give them this shop drawing. Finally, I know we're 5 minutes over time. We did start 5 minutes late, so we're almost on the hour. We have bathroom pods. And if you look at what's happening with design for fabrication and assembly, bathroom pods or precast houses or parts of precast houses or hotels and stuff can be very popular. So this is where we move, say, outside of the collections to use tools like Inventor. These are some images that were provided to me by Foster & Partners on the HSBC Hong Kong Tower. They did these bathroom pods that were fabricated in Japan and then shipped on the site and then installed in the building. They did this because they had to meet a very tight schedule. It's a great way, though, to speed up the design of the building and then assemble it on site. Back in their day, when they did this building, they made models to work out all these pipes. Again, you know, when you're doing pods and you've got a heavily serviced building, all of this needs to be worked out. So they didn't have them back in the day when they did this building, so they were heavily using models. Now, you don't need to make cardboard models. You can do it all in Inventor and bring it into Revit. So Inventor, it's not inside the collections, but it's just something to consider if you're working with a manufacturer. You can bring in this LOD 400 data and then connect it into your Revit systems. So what I got here is a bathroom pod that was worked up by Matthew McKnight, and you can see everything is worked out here. Every bit of secondary steel in the wall, so your steel studs right down to the hand basins and the screws and how the partitions are all fixed to the wall with some of the services. So this is a fabricatable model. You could take this into the factory and you could use it to fabricate from. Now, what Matt can do here inside of Inventor is export it out as an ADSK file, and I can import this Inventor data into Revit. So here we have that same bathroom pod, and you can see all the detail. It's all come through clean. I can import it in, and then I can start to use it inside of Revit. So if I want to connect it up into the services of Revit, I can go and draw pipes out of that Inventor model and then connect them into my existing services inside of Revit. So here we have our supply pipes. I'm going from the Inventor model into Revit, and that's now connected up the two supply pipes for the hot and cold supply feed inside of my Revit model into my Inventor bathroom pod. So it's pretty cool. So that was the last bit of the presentation. Now we've gone through quite a bit today. Ty is recording this, so if you need to rewatch it, there's a lot there. If you do have any questions, please drop them into the chat window. I'll do my best to answer them. But we've just as a recap here, we've gone through our surveying and urban design or master plan design with Recap Pro for photogrammetry and laser scanning, Civil 3D for working with topography information and linking into Revit, InfoWorks 360 for conceptual design and pulling down site information, 3ds Max for conceptual building design and schematic design, Insight 360 for solar or day lighting analysis, and Civil 3D for wind wake analysis. Then we covered some of the new things that are available in Revit 2020 plus Dynamo Studio and Dynamo Player. BIM 360 design we touched on, and then finally we were finishing up with the LOD 400 section with Advanced Steel. We touched on some Navisworks and Inventor. Okay, and that's everything. And we do have a few case studies on our website. Daiwa House is doing some incredible stuff, futuristic stuff with machine learning. Okay, so just a reminder, any questions, please feel free to type them in the chat box, or if Ty's getting any questions coming in. Okay, well, if there's no questions, Ty, do you have anything to add? Maybe put it in the chat window because your mic's not working. Okay, all right, well, thanks. Thank you very much. There's a question there, Ty, for sharing the presentation. So yeah, it's been recorded. Ty will be able to share that out on the GoToMeeting service. Yeah, any further questions beyond this after you've rewatched the recording, Ty has my contact details, and I'll be more than happy to help answer any questions about some of the content we've shown today. So thank you very much for your time. I'll finish up there, and any questions, please reach out to Ty and the team at Advanced Spatial, and they'll be able to direct you in the right way on the AEC collections. Thanks very much.
This conference will now be recorded.